Okay, continuing, you will notice that we had one case where the function was defined and one case where the function was not defined, the exact same function. So what was not mentioned there was what is called the domain. And unless otherwise specified, we will assume that the domain of a function f to be all the real numbers for which the function f of x is defined as a real number. And we refer this as to the natural domain of the function f. So let's use these two examples to illustrate what we mean when we're talking about a domain. So we have here exercises ask us to find the domain of each of the functions. So we have A and B. In part A, we have got a function f of x equal to 1 over x minus 3. So the domain is all real numbers x such that this function f of x is defined as a real number. All right. So I can tell that there could be a problem or there could be a challenge in getting a result if the denominator is 0. So the first part, I want to emphasize that for a rational function, for a function, a rational function, the denominator must never be 0. Must not be 0, okay? Not be 0. Okay, so what do I mean by that? So the domain, in other words, we're saying that the domain is all x where the denominator is not 0. What's the denominator? The denominator is x minus 3, and we are saying this is not equal to 0. That's what we want. Now, how do we compute this? What does it tell us? We see that the only x value that makes this 0 is 3. How? We just take the negative to 3 to the other side, and then we have the x not equal to 0. X not equal to 3. All right. Even though this looks sufficient, it's not a mathematical way of presenting it. I'll write it this way. It's D, which represents the domain, is equal to this bracket here is telling us the set of all x numbers that are in the real numbers. So real numbers are, we write it in a special R like this one, where this is saying such that or where x is not equal to 3. This is the appropriate way of writing this answer. Now, in the second case, what do we see? We've got g of t, which is equal to the radical of t minus 2. So this expression has a problem in only one case. The only challenge here is this following. For a radical function, we want the input must never be 0. There must never be negative. The input must never be negative. Must never be negative. Negative. I'm finding an English way to say this. But what we're simply saying is that negative. Sorry. What we're simply saying is that whatever goes under the radical must always be positive. Now, what do we mean that? We know that our g of t is equal to the radical of t minus 2. So everything under the radical must be positive. Everything under the radical must be positive. So what we mean to say is that the domain is all t values where t minus 2 is larger than or equal to 0. We definitely don't want it to be negative. In other words, if you take the negative t to the other side, then it becomes t greater than or equal to 2. In conclusion, as I did above, we can write it in proper mathematical notation. We say that the domain D is all real numbers. This is the set of all real numbers, x in the real numbers, okay, where or such that t, oh, by the way, we're not dealing with x, by the way, I apologize. make sure that you are conscious of the letter T in R such that T is greater than or equal to 2, and that is our domain. Okay, so in this video, we were just looking at the domain of a function.